Welcome to part 2 of chapter 16, Mineral Resources. Today we're going to start with looking at how do they process the minerals. And basically what we have over here is a smelter pot. And you can see, and this is showing iron ore. And they smelter the iron, and the ore gets so hot it becomes liquid. And you can see coming out on the right hand side the molten slag, or what's left over, and the actual iron, which is very, very heavy, drops out to the bottom, and the slag kind of floats to the top and oozes off to the side. And the process, obviously called a smelter pot, it's called smelting. And this is one of the things when they're trying to extract something, they use this system, and that slag is waste material. So it's got other heavy metals in it, and it can have other toxins such as arsenic. Selenium can be in there as well. Not so much, but sometimes. Next we have the tailings, the overburden, or the spoil. And on the average, you've got about 80% of this mined ore becomes tailings. And these are toxic. Oh, and here we go. It's got mercury, cyanide, sulfuric acid. And this can leach into the environment, can cause a sterile area around the mine because the land cannot tolerate growth of plants, and also the water becomes sterile as well, any water next to it. Just to give you an idea, just so you can have 2 gold wedding rings, your engagement ring and your wedding ring, takes about 6 tons of waste to produce just that little bit. So basically 6 tons equals 12,000 pounds of waste. So are wedding rings worth it? You have to look at the environmental cost of your wedding ring. This is the act that required all land to be restored. 1997, it took before this act had any meat to it, and actually made the mines go back in and change from what you see barren there. They had to go back in and reconstruct the topography. We talked about this in chapter 11. Put the area back the way it was, completely, with trees and everything. What you're seeing here, this is pictures of Ducktown, Tennessee, or the Copper Basin area in Tennessee. And that mine was mined out in the 1800s. They mined the area as well as deforested it, because back then smelter pots were actually run off of trees. So they cut down the trees in the forest and bring them in and use them in the smelter pots. So not only do you have toxicity going on from the slag, but you also then have deforestation. And because of the loss of topsoil up in the left-hand corner, probably right, you see what it looked like. Now, this is what it looks like. The first time they tried to revitalize this area, they went in and hand-planted lots of pine trees, the native trees that were there. But because there was no soil with nutrients in it, they all died. Everything died. They planted low-lying plants, they planted taller trees, and they couldn't get anything to stick. And because the soil needed to be remediated, and it needed fertilizer. So what they ended up doing is dropping seeds from planes and just over covering it and then continuing to put fertilizer on it to get some things to grow. And they really had to start with secondary succession, and where you got your grasses and your small plants to grow, and you build up that root base, and then of course trees will grow, and you'll get topsoil eventually laid down so that it looks like what it does here. But if it had not been for the Surface Mining Control and Reclamation Act, some of these lands would not be restored. Now remember, I told you when we were talking about the coal mines how they got past that. They were washing the coal, and the coal wash busted up into one of the rivers in Virginia, and it contaminated drinking water for millions of people, and the company went bankrupt. Then this Reclamation Act doesn't work because they say they don't have any money to fix it. Many of the developing countries, such as Africa, have minerals, and there's mining processes going on. These countries are so poor that they do not have laws regulating mines. So not only do you end up with uncontained tailings, slag being put into rivers, you have child labor, and someone's making a huge profit off of these. So are those countries, are they being compensated financially? Are they being helped with health care? Is it respectful to treat them that way for things that we want? And not really an environmental question, but kind of a soul-searching question. We're tearing up their environment indirectly because there is a market for what they have, and they have no basis but to accept what's being done. These are manganese nodules. They lie at the bottom of the ocean, and the graph shows you where these are. And the manganese, there's copper, cobalt, nickel. And the thing is, they're in international waters, so who owns them? Who can harvest them? At this point, these things are still on Earth, in the ground, and we can get to them without going thousands and thousands of feet down in the ocean and pick them up. But when we run out of copper, and if you'll remember from part 1, we're not very far from running out of copper, within your lifetime, definitely, then what do? Do we fight over these nodules at the bottom of the ocean so that we can get that last little bit? Interesting perspective. And what kind of environmental damage would that do in our ocean waters just to get the manganese? At this point, it's too expensive, and I won't say nobody's thinking about it, but technology is not there to do it in a cost-effective way. And certainly in international waters, who looks over the environment? Whose responsibility is that? When we talked about fracking, when we talked about the shale that they're fracking into, and how it used to not be a viable source of natural gas or oil because there wasn't enough of it and it was expensive to get to. So when I talk low-grade ore, that means I've got a piece of rock and it's got a little bit of the substance in it I need or I want, but not a lot. And so that low-grade ore might not be cost effective to get whatever I want out of it. So they're working on experimenting with biomining and phytomining. Biomining using bacteria, and they also add some sulfuric acid to kind of break down things, and then the bacteria actually release the copper from the ore so that they can easily get to it. Phytomining is basically the plant uptakes the minerals, then when the plant is completely full of mineral, you harvest the plant, burn it, and then isolate the minerals in the ash. So then you would smelter it a little bit more to liquefy it and then let the minerals settle out. And so this is a plant that they use for phytomining. Phytomining comes from phytoremediation. We can use plants to uptake heavy metals and different toxic substances, and phytoremediation is trying to suck that toxin out of the ground. But when you do that, then you have to cut the plants off and remove them from that area. You can't just let them suck it up and then die and decompose there, because you're just putting it back in. One thing that takes up a lot of phosphorus, cypress trees, which are natural here, and good old cattails. Cattails suck up phosphorus, but cattails tend to be a nuisance plant. And that's phytoremediation. Phytomining is actually so you can get the minerals out of there. That's why they call it mining, because you're using the minerals for something. Looking at life expectancies, these are in thousands of metric tons, how much we have. Now before you saw years, and this will give you copper, and this is world reserves. Copper about 22 years, iron ore 65, and 81 for bauxite. But aluminum is very, very recyclable. Once again, very, very recyclable, and the carbon footprint is minimal compared to the carbon footprint of creating a brand new aluminum can. So if you don't recycle anything else, recycle aluminum. Substitutions. Can we substitute? Can we come up with different things so that we're not taking these precious metals out of the ground? That helps. It needs to be inexpensive, and it needs to be either a recyclable entity or something that we have a lot of. Example, we're using glass, plastic, aluminum instead of tin. We used to use tin. There's almost no tin available anymore. And that's where you get tin cans from. Now they're aluminum cans. And glass and plastic. Plastic, though, is a petroleum product. How long will we have that? We don't know. But it's very important to recycle all of these things so that we can use them again and again. When we look at mineral conservation, we're looking at two things. Trying to manufacture it sustainably so that we have the least amount of waste of that product, so we're using as much as we can of it. And that's just recovering the waste so that it can be utilized again. And we also have dematerialization. And let me explain dematerialization. The first telephone, cell phone, hand phone, was like a brick. And in fact, people call it brick. Very large, very heavy. And now you literally put it in your pocket. And it can do a lot more than that first one did. The first one you could make a phone call. This one you can run your life off of. So that's dematerialization. You're decreasing the rate of the product, decreasing how much of the mineral that is needed to go in there. So that in itself is a good thing. Now, if you dematerialize, but the product doesn't last as long, then you're really not increasing the good, because then you've just got to make more of them to do the same thing one of them would have done, like washing machines. Washing machines used to last, 25, 30 years. Now you're lucky if they last 15. And they're a lot lighter. They use less water, but they don't last as long. So you're getting some benefits, and then there's a solid waste issue that we have to deal with, as well as using the metal and being able to have that steel and iron like we used to. We get into our 3 R's: reduce, reuse, and recycle. And this is huge. It's huge because minerals need to be conserved. We need to reuse them. They are a finite product. And to add to that, we need to keep things out of our landfills. Because people don't like to be around landfills. They're filling up. And it's hard to find a place to put all the trash. So, which we'll talk about in the last section, the very last unit we talk about. So, with mineral conservation, reducing, dematerializing, reusing until that thing is out of commission. Not just because the new iPhone came out, am I going to get the new iPhone? I wait until mine quits working. Recycling, taking that apart, using all the usable pieces of that phone and remolding it into something else. That's recycling. That is the end of chapter 16.